this is a tour of a 6-star system. So we're gonna start at the A section of the system and the AA section. The first planet in the AA star is this hot Jupiter. This is the physical compound and its internal structure containing hydrogen, helium, water, envelope, silicate mantle, and metallic core. This is its climate with 334 as its minimum and 537 degrees Celsius as its maximum. Its atmosphere is hydrogen and helium mostly, and the orbital eccentricity is 0.3%, and that's all. Here's some more stuff. This is the second planet in the AA star system, and here's a cool fact about living very close to another star, is that when you go on the night side, the other star, the AB star, is going to illuminate your night sky and destroy your night sky view, meaning you'll never experience a nighttime ever again. Actually, sometimes. You can still see nighttime. So this hot Eritrea, this planet has water mostly in its atmosphere, but not as a liquid, just as a vapor. And nitrogen for 11% of it, CO2 as 4.23%, nitrogen and this for 1.94%. The climate, its rotational period is about 7 days, and its orbital period is 11 days, meaning it is not entirely long, but it still takes 22 days for a solar day in this planet. This planet is also very hot, with 284 at its minimum, 348.62 at its maximum, and its average 318 degrees Celsius. Its orbital eccentricity is 4%, which is good, which means it sometimes goes close to its star, which is its pericenter, which is its closest to its star, and its apocenter, which is the farthest it gets from its star. The last planet in the AA star is this warm gas planet, mini gas planet. The planet has a high eccentricity, meaning it gets to its closest point at 0.13 AU and its farthest at 0.15 AU. Its atmosphere, once again, mostly water for some reason, meaning the entire planet's gas is mostly just water vapor. Water vapor, that's all. It's also cold. It's also hot as well. 135 degrees Celsius at its average, 55 degrees Celsius at its minimum, and 162 degrees at its maximum. It has an ESI of 69%, which is not bad, but it's not like Earth. So, and it's also it doesn't have a solid surface, as seen here. It's time to go. The AB stars do not have any planets in them. However, there are 2 planets that are orbiting both stars, so we're gonna go to these first. First, A1, which is a frigid planet. It's actually kind of cold, with negative 212 degrees Celsius, and it has 4 moons, which 3 of them are big moons, and one of them is a dwarf moon. So we're gonna go to its moons and this planet. The planet's composition. The planet's composition is mostly water, silicate, and a metallic core. Its atmosphere composes of mostly nitrogen, CO, neon, and CH4, and some argon. Its eccentricity is only 1%, meaning its orbit doesn't really change that much. However, the farthest point is 6.4 AU, and the closest is 6.3 AU. The climate is also the rotational period is 19 hours, and its orbital period is 16 years, orbiting 6.35 AU from its star. The gravity is less than the Earth, and and once again I said it's cold, and its ESI is very low, 20%. And because of its rotation period, you'll only experience up to 9 hours of daylight, which is less than the Earth or mostly the same amount of daylight you get in the winter time on the Earth. Now it's time to see its moons. The first moon is a frigid micro-Aquaria, which is a small planet only having a diameter of 894 kilometers. And I forgot to mention this, 10,850 kilometers for this frigid arid Aquaria. The first moon is 894 kilometers, and it's mostly composed of water, silicate, and metallic core. The second is 2,000 kilometers, which is very big, which is the farthest moon, which doesn't have an atmosphere like its other moons, and it has the same composition with its climate also being very cold. The second moon is this one, which actually is another Aquaria, and it's 1,400 kilometers. It's mostly water at its surface, silicate on after that, and then finally goes into a metallic core like everything. Every moon on this planet is tidally locked to A1, meaning it is one side of its moon will always face towards the planet, and the other side of the moon, just like the Earth's moon, will never see it. The last planet in the A star section is actually a binary planetary system with A2A, which is over 13,000 kilometers, and this being only 5,000. And also, because of the binary relationship, there could have been a huge collision, and it made its actual tail go almost lopsided. And just like mostly all our planets, mostly has water and ice, meaning there could be water underneath or ice on the surface, silicate in the middle, and the metallic core. It has an atmosphere containing mostly nitrogen, CO, CH4 with 0.9%, nitrogen 93%, neon 0.42%, argon, which is 55.2 parts per million. The orbit is not bad, it's mostly stable, but its actual tilt is actually very big. And didn't I forget to mention, this star system is 600 million years old, which means it's very new, and planets are just cooling down at this point. The companion to A2A is a frigid arid Aquaria, sub-Aquaria, which takes 5 days to rotate, and its atmosphere is slightly less. And it's just like, because its actual tilt says 0, it's actually just orbiting, its actual tilt is the same as A2A, meaning it's also lopsided. Just like A2A, its atmosphere is mostly nitrogen with some CO and argon. It takes 5 days for the companion planet to orbit around its host planet, A2A. Now we're going to show you something I didn't say before for the AA system. So AA1 is diameter is 142,644 kilometers. This one is 8,824 kilometers, and this one's 11,219 kilometers. And surprisingly, for none of the planets are tidally locked, as all of the planets have a 2 to 3 orbital resonance. So now I'm just going to end the video here, and in the next video I'll be showing you planets in the B star system, which is this one, which contains more planets. And thank you for watching. Please subscribe.